Hi and welcome friends. So today I am going to show you how to read input at any GPIO pin for STM32 microcontrollers. It will be the same tutorial as we did in our previous tutorial. The only thing I am going to use different boards today. So I am going to use STM32F401RE, that is a Nucleo board. And also I am going to do the same thing for another board in this tutorial, which is STM32F107BC. So basically I wanted to show you what are the differences come when you change your microcontroller, like from one microcontroller to other, because STM produces more than 700 microcontrollers. So developing a tutorial for each of them is a pretty hard thing, and you'll get an idea how to write a code for your own board. Also, I'm going to use the same workspace which we have created in our previous tutorials. Like in the first tutorial, we have created a workspace for STM32F107BC. In second or third tutorial, we have created workspace for STM32F401RE microcontroller. So we are going to use the same workspace. So let me first open the F401. So this one is the F401 workspace. Let me open this. Okay, so here is our code. This is the code for blinking the LED for STM32F401RE board. Let me once again check the board. So yeah, this code is for STM32F401RE. Okay, so we are going to modify this code to read the input, and to do so we need the input pin at what pin the switch is connected. So for that you need a schematic of that particular board, or in my case Nucleo board. So I have already downloaded the schematic, and let me find it. So I think it should be somewhere in documents. Yeah. Okay, so here is the schematic for Nucleo board, and if you are using Discovery or Evolution board, you can download the same thing from STM website. So the name of the switch is user, so we need to search for the user, and here is our switch, user switch. So user switch is connected to ground by one side, and other side is connected with a pull-up resistor and connected with a VDD, that is 3.3 volt. So what does it indicate? That if you press the switch, the line will become grounded or 0, and if you leave the switch, the line will become high or 1 or 3.3 volt. So this pin is connected with PC13. So what we need to do, we need to configure that port PC13, that port C peripheral, and in that peripheral we need to configure clock, then the particular peripheral, and then we can write our code for reading or writing the instructions. So we first start with writing the code for activating the peripheral. Okay, so also as we know that there are three buses in that particular microcontroller, that F401 microcontroller. For that you need data sheet of that 401. So this is the data sheet, and if you go little bit down, yeah, so here is the block diagram of that microcontroller, and if you can see that the ports are connected with GPIO ports are connected with AHB1 bus, that is a high speed bus. So we need to configure this port C. So what we write, we first enable the clock for that port C. So we need to enable AHB1. So we can copy this and paste it here, and just a small change, that is port C. So we have enabled the clock for that particular peripheral. Now we need to configure that particular pin or particular port for input. So what we do, we'll copy this whole thing. The procedure is almost the same, like there are multiple parameters which you need to configure, like push pull output. So we'll copy this whole thing, and the pin number is 13 if I'm not wrong. So let me check once again. Yeah, so pin number is 13 and mode should be input, Speed is same, so you can delete all this because already you have defined those things here. The elements will remain same. Actually we are modifying this variable, this type definition variable. So if we do not make any changes to that, like for example initialize GPIO speed, if we are not going to change this, for example I copied this and I write, so here I changed this, but if I am not going to write anything, so it will not be changed. So we can only copy those parameters which are going to change. For example, in this case only the mode will be changed. So now what happens, the element of this initialize GPIO, this variable, pin number is changed, GPIO pin is changed 13, mode is changed, but the rest of the things will remain same. And what we will write here, GPIO initialize port C. So now we have initialized that pin as input. Now we'll refer to our this peripheral library and we'll see what is the command to read a particular pin. So here is the command. So we'll copy this and we'll write it here and we'll see what are the parameters. So GPIO X, that is GPIO C, then pin GPIO underscore pin underscore 13. So we are writing this, it means that we are reading pin number 13 of port C. And I will also define a variable because it is a return type function. This function will return something that is high or low. So we will check it here. So as you can see, there is a return type, and that return type will give you either 0 or either 1. And now if int C will get that value which will you provide to that particular pin, high or low. So what we will write, we'll write if C is equal to high or 1, then what should happen, this command should run, else nothing should happen. Okay, so now in this case the LED will only blink at that particular condition when the C port is high. So actually I made a small mistake, I think. By default port C is high, that means if switch is not pressed then this line will be high, so I have to make a small change. Okay, so now our code is ready. So this is the code to read the input. It is very simple with respect to the previous one, because here settings are very less. We did very less settings because all the settings are previously done before. Now let us write this same code. Before that, let me compile this. And also let me open that project for F107VC, that is connectivity line. Okay, so as you can see, I think the code is compiled and total errors 0 and warning 0. So this is the code for reading the input. So only thing you change is you set the mode as input and you use this particular function to read the input. And now let us write this same code for 107. Okay, so in case of 107, I think I did something. Yeah. Okay, so this code is also for blinking the LED with a different type, but let me remove all this. Okay, so we'll write this code from scratch. As you can see, this board is 107VC. So right now we have set up the environment. Also I will delete this and delete this. So first thing you need to do, you need to set up the clock or activate the clock for a particular board or microcontroller. So let us go to the, now in case of 1 series, the documentation is not good. Actually here nothing is given as compared to the previous one. You can see here, there a good documentation was there. As you can see, how to use this driver, you have to do this, but here nothing is there. So now you have to refer to reference manual, which is around 1100 pages. But we have some idea, like the first thing we need to do, activate the peripheral clock, then activate that peripheral or configure that peripheral. So we'll go by that method. The only thing we need to find which particular bus it is connected. So for that again we need the data sheet. Yeah, here is the data sheet. Okay, so let me find the block diagram. Yeah, here is the block diagram. So in this case the ports are connected with APV2 bus, that is a peripheral bus. So we have to activate this particular bus with that particular peripheral. So in this case this actually microcontroller we are taking it, but there is no such Nucleo board available for 107, I think. So what we will do, we will consider that, suppose that the LED is connected to port B, pin number 5. So we will activate that port B and pin number 5. So let me use this, and we will find that command. Actually, what is the command, what is the function to activate particular clock. So for that we can go to rcc.c library, and we'll go here. Okay, sorry, where is the functions? Okay, I think functions are declared in .h file. Go open .h file, and here's what, man, where are the functions? Yahoo. Okay, so it's pretty difficult to find functions like this, but we'll find it. RCC. So you have to do some research or something like this. Get system clock. Actually it should show the functions, but I'm not sure why it is not showing like this. Okay. Yeah, here is the AHB bus. Similarly we have to find APB2 bus. So let me copy this, find APB, what is the bus? APB2. So we'll write APB2, find. Yeah, here is the bus. So it takes 2 arguments, as you can see, and 2 arguments you can find here. So as we have considered port B, pin number 5, so we'll activate that particular bus for port B. So let me first copy this thing. Okay, then it is not taking anything. It should display the contents which this particular parameter will take. So APB, yeah, port B, and then enable. Okay, sorry. So now we have enabled the particular clock. Now suppose that the switch is connected with the same manner which previously it is connected, and the same pin. We are supposing these all things, but actually there is no such board available, so we'll go with this only. And again the port C is connected with, yeah, port C is connected with same bus, so we can copy this whole function. So these are the small changes which come. If you copy that code to this particular board, it will not work because buses are different. Okay, so we have enabled clock for port B and port C. Now we have to configure the GPIOs again. So to configure the GPIO, we know that there is one function, or we need to define a type definition variable, structure variable actually. So why it is not working? Okay, read input data, read output data. See mapping. Please stop me if you find that particular function. Deinitialize. Yeah, it should be initialization. Yeah, here is the function for initialization of pins or port. Now we have to go to structure. Here. What is that? Jaise Sitaram ho gaya. Okay, we have to again find the structure. That should be in .h file. Yeah. So here is the initialized type definition, and as you can see, there are 3 elements in this code, but with compared to that previous one, we got multiple. So as you can see, there are 5 elements. So there are GPIO pin, GPIO mode, speed, O type, and then PUPD. But in this case, only 3. So these are the changes which come. So you need to read the library function if you are going to program with the help of libraries. Okay, so in this case actually what happens, this mode will accept 8 values, which is the combination of all the values which you can define with 5 different elements. Let me show you. Let me first define this. So yeah, and init definition, any variable name you can give. So the first thing is init underscore definition. Again it is not coming, I don't know why. Am I making any mistakes? Init type definition. Init type definition. Yeah, we are doing right. Let me compare with the previous one. GPIO initialized type definition, and here what we have written, GPIO initialized type definition, init GPIO init definition, and it is not coming. So some problem with the IAR, I think. So we have to give everything manually. So first parameter is pin. Actually it is not referencing. Okay, so pin number is GPIO underscore pin underscore 5th pin. Okay, and the second variable is let me compile this. Okay, so some error is coming. Was set but never used. Okay, again let's see. Everything is happens with me only. Now the second thing is speed we have to set. Now for speed, in the previous case speed was a little different. In this case we have to define it differently, and again it will generate. okay, differently. For example, now if you go to speed, you will see that it accept different parameters like medium speed, fast speed, high speed, but in this case the parameters are different. So we'll use 2 megahertz. You can use any one of them, depending you cannot cross the bus speed. Okay, so speed we have defined. Mode left initialize underscore definition dot. There is the mode. And mode, you can see there will be many options. In previous case mode there was only I think 4 options, that is input, output, alternative function or analog. But in this case you can see 1 2 3 4 5 6 7 8 modes are there. So these are the combination of your different elements which you used. Like in previous case you used different elements like mode, O-type, PUPD, but in this case they combined all these mode, O-type and PUPD. Like if I show you, so the first one is AIN. I think it stands for alternative mode input. I'm not sure. Then it comes input floating, input pull down, input pull up, output open drain, output push pull, alternative function open drain and alternative function push pull. So AIN I'm actually not sure, but AIN then should be standing for analog function, I think. So one thing you can do, you can search for this. What is the meaning of this? You can find this on the internet. But in this case we are going to use output and push pull. So we'll copy this. So what they did, they combined all 3 things into one. Okay, so we have defined, or what we can say, we have given values to different elements of that particular structure. Now we'll use GPIO initialize function. So that function should be here. Deinitialize, it is initialize. We'll copy this and write it here. Again it is not taken. GPIO port number B we have chosen. B GPIO, no, you have to give address of that particular variable, structure variable. So I will write init underscore definition. Okay, let me compile this code, see whether it is working or not. Okay, so it is working. We can proceed forward. Okay, for output now we have to write code for input. So let me copy this again, and we are using same variable because the use of the variable is over in this line, this variable init def. So we can use this variable again, and we will change only those values which are different. So mode will be input. Let me check again what is the mode. So input is input pull down, input pull up. So we'll use pull up because by default the schematic showed that it is pull up. So we'll change this, and rest of the things will remain same. So I will delete this. It unnecessary. You can give it or you can delete it because you are assigning same value again and again. Doesn't make sense. Okay, so we have written our code, not complete code actually. We have initialized everything whatever needed. Now we will write our code in while one, that is infinite loop for all the microcontrollers. Okay, so the first thing I need to write is I need to read the pin. So let me read the pin first. So for reading the pin, you can go to here and we have to find function for reading the pin. So GPIO initialize, then comes structure initialization, read input data bit. So this is the command and it will return the value type integer 8-bit. So let me copy this whole thing and GPIO pin underscore 13, this is our pin, remove this, and GPIO port C, as we have enabled port C, and we'll assign a variable. Okay, so now what will happen, whatever value will come to port number pin number 13, it will assign to variable C. Now we'll write the code. If C equal to 0, then LED should glow. So for glowing, again there will be some output parameter. I think setBit is the command. So here is the function. Let me copy this whole thing because it is not referencing anything. So paste it here, GPIO pin number 5, and delete this, and port number A, okay, B, delete this. Okay, so we have set the bit if we press the button. Now if we have not pressed the button, then else the function is reset bits. Okay, so the code is completed and you can run this code and check with your hardware. If you have a 107 VC microcontroller interfaced with some hardware, and here is the error because we have defined it again. So let me delete this. Okay, so this is the code. So as you can see, very small differences will come, and sometimes very large also. Like in this case, the complete structure of this particular definition or particular setting up the registers and all is changed. Like in previous case, as you can see, it was quite different. Also, we have made some changes in this for setting up the environment in case of 107. So here you can see the difference in both the code. And let me open the code which we have did in previous tutorial. The same blinking LED code for key press. So L series. This is the code we have written yesterday, I think. And also I used mainly 3 series board, that is F4, F1 and L1 series. So documentation was there in L1 series and F4 series, but only for F1 series the documentation was not good. So for F1 series you have to refer to many places. So you can search for the internet to find the answers, or you can use reference manual. But reading reference manual is another big task. Okay, so here is the code for F1 series, F4 series, and let me open L1 series. Okay, so this is the L1 series. So L1 series and F4 series is almost same. I think these two are updated libraries because the documentation was also good for L1 also and F4 also. So you can see the difference. Here AHB1 is there, here AHB only. Okay, so these kind of differences. If you open the data sheet for L1, instead of this AHB1 here, you'll find only AHB 84 MHz or 34 MHz, whatever frequency, maximum allowed frequency is there. Also, I don't think there is much difference in both the code. Both the code are written for STM Nucleo board, and pin number, pin configuration are almost same. Okay, so this is the way you can develop your codes for different boards. Suppose you are using Discovery board, which are much cheaper than Nucleo boards, so you can use these things like reference manuals, functions or libraries, datasheet to get the answer, or you can search for internet. Okay, so for today's tutorial this is it, and thank you for watching, and do like the video and subscribe it, and see you very soon with new tutorial. I think in next tutorial I will show you how to read reference manual, datasheet, and how to use reference manual to write your code without using standard library functions like these. Like then you have to configure the register bits. Okay, so thank you for watching. Bye bye.